Imagine a robot that does not just follow commands, but can actually think, plan, and even search the internet before it acts. This is no longer science fiction. This is Gemini Robotics ER 1.5 from Google DeepMind, a model already being called the advanced brain for robots. In this video, we are going to explore what it is, how it works, how it is different from traditional robots, and what it means for our future. Traditional robots were built to follow fixed commands. Pick this up, move that over there, repeat the same action. The problem is that the real world is unpredictable. Tasks change, environments shift. What we really need is flexibility. DeepMind's solution is embodied reasoning, a way for robots to connect vision, language, and action so they can reason about the physical world. Gemini Robotics ER 1.5 is the step that bridges perception and action, bringing intelligence into motion. Gemini Robotics ER 1.5 integrates three essential skills: visual and spatial understanding, task planning, progress evaluation. It can also invoke tools directly. It can connect to Google Search, use vision language action models, or call hardware APIs to complete complex tasks. The model has been validated on academic benchmarks and in real-world scenarios. It achieves industry-leading performance while still keeping the power of a general-purpose multimodal foundation model. First, high-speed spatial reasoning. By using the low-latency Gemini Flash model, it can generate precise coordinates, understand attributes like size and weight, and follow interactive commands like point to all pickable objects. Second, advanced behavior orchestration. It can plan and execute long-term tasks, such as organizing a desk based on a picture. It checks its own progress and even uses external tools when needed. For example, looking up trash sorting rules in a local city. Third, flexible thinking budget. Developers can adjust the balance between speed and accuracy. For a quick object detection, you can set a short thinking budget for instant response. For a multi-step assembly task, you can extend the thinking time to maximize accuracy. Fourth, stronger safety filters. On the semantic side, the model rejects dangerous task plans. On the physical side, it knows when a request breaks the limits of the robot, such as lifting an object that is too heavy. These mechanisms reduce risk both at home and in industry. Gemini ER 1.5 can take a vague instruction and break it down into concrete steps. For example, the command, "clean the desk." The model automatically generates a sequence. Move the pens, stack the papers, wipe the surface. It then calls the right tools. A hardware API for moving the robotic arm. A grasping model to hold objects. A VLA controller for precise movement. In terms of space, the model can identify the exact coordinates of items in a kitchen, such as dish soap or a drying rack. Combined with 3D sensors, it creates detailed motion plans. In terms of time, it can analyze a video of a robotic arm and output a second-by-second breakdown. For example, at 0015, the left arm reaches toward the blue pen. This shows a true understanding of cause and effect in the physical world. One demo shows the robot preparing a coffee. It can answer where to place the mug and where to put the capsule. It even generates the trajectory points needed to close the lid smoothly. Another example is trash sorting. The robot checks the rules for San Francisco, then applies them in real time to separate waste correctly. In a packing scenario, the robot builds a travel bag. After checking the weather in London, it adds an umbrella to the items. In office tasks, it can watch a video of a desk being organized and then reproduce the steps with precise timing. DeepMind stresses that safety cannot rely only on model filters. Developers must implement engineering layers as well. That means emergency stops, collision avoidance, sensor barriers. This creates what they call the Swiss cheese model of safety. Multiple overlapping protections that catch mistakes before they turn into accidents. Gemini Robotics ER 1.5 is already available in preview through Google AI Studio and the Gemini API. There are developer docs, quick start guides, and Colab notebooks to make it easy to experiment and then build real applications. This lowers the barrier for advanced robotics. It opens the door to new apps in home services, manufacturing, and logistics. This is a shift from specialized machines to general-purpose assistance. In homes, we might see robots helping elderly people, cleaning rooms, or preparing food. In factories, robots could assemble parts, check quality, or manage inventory. In logistics, they could sort packages and load trucks, and long-term, we could even see teams of robots coordinating like swarms, all powered by the same intelligent framework. Gemini Robotics ER 1.5 is not a conscious being, but it is a major leap toward robots that think and act with true intelligence. The question is not whether the technology works. The question is whether we are ready for robots that make decisions in the physical world. So what do you think? Would you want a robot in your home that decides how to complete tasks? Leave a comment below, hit like if you enjoyed this breakdown, and subscribe to the channel for more deep dives into the future of AI and robotics.